We are going to learn about pointwise and uniform convergence. We shall start with the definition of pointwise convergence. By definition, we let our f of n be a sequence function defined on S contained in R. This implies that S is a subset of what? R. And R for this instance is what? The set of real numbers, which ranges from negative infinity to infinity. We say that f of n converges pointwise to a function f on S if limit, we introduce the limit as n tends to infinity, of fn of x, which is equal to what? Our f of x for all x member of what? S. And remember, S for this instance is what? The subset of R. We go ahead and define uniform convergence by definition. We let f of n be a sequence defined on S contained in R. S a subset of what? R. For all x member of what? S. For this instance, x can be any element in between what? Negative infinity and what? Infinity. And let n be dependent on what? Epsilon. And remember, epsilon is any number greater than what? 0, which is a member of what? Natural number. There exists an epsilon greater than 0 and n greater than what? N dependent on epsilon. For the absolute of fn of x minus f of x should be what? Less than epsilon. That is now the definition of what? Uniform convergence. We can apply the concept of pointwise convergence and uniform convergence to solve the problem above. Test for the uniform convergence of fn of x and f of x for. You have been given fn of x, which is 2xn plus into negative 1 power n x squared over what? Over n. And you have been given your f of x to be equals to what? 2x. To test for uniform convergence of this function, we shall start by doing what? Checking the pointwise convergence. Solution. Pointwise convergence. Pointwise convergence. We introduce the limit as n tends to infinity of our fn of x minus, it should be equals to our f of x. This is the formula of testing for pointwise convergence. And you have been given your fn of x, so you will solve this. Whatever you will get, if it will be equals to 2x, then this implies that what? It's a pointwise convergence function. So we say fn of x is equals to limit, we introduce limit as n tends to infinity of what? 2xn all over n plus limit as n tends to infinity of what? Of negative 1 raised to n x squared over n. We go ahead and solve the problem. Fn of x is equals to limit as n tends to infinity of 2xn over n. N goes with n. Plus limit as n tends to infinity of negative 1 raised to n x squared all over n. Remember, n tends to infinity. N tends to infinity. So where there is n in this problem, we shall replace with what? Infinity. And the entire of this system will be equals to 0. And we remain with our fn of x to be equals to this 2x. Since 2x has no any variable of what? N. Will be equals to f of fn of x will be equals to 2x. Recall. For pointwise convergence, we say fn of x should be equals to what? Our f of x, which is equals to 2x. implies that this problem is what? It's pointwise convergence. We go ahead and test for uniform convergence. Uniform convergence. Uniform convergence. You have from the formula the absolute of fn of x minus f of x absolute should be less than what? Epsilon. We write that way, epsilon. So we introduce absolute of our function, which is 2xn plus into negative 1 power n x squared all over n minus f of x. Our f of x is 2x. Should be less than epsilon. So we say our absolute of 2xn all over n plus into negative 1 power n x squared all over n minus 2x absolute is less than epsilon. N cancels with n. So we say the absolute of 2x plus into negative 1 nx squared all over n minus 2x absolute should be less than epsilon. If we subtract negative 2x, if we subtract 2x from 2x, we get 0. So we remain with negative 1 raised to power n x squared all over n absolute should be less than epsilon. And our choice of n is a number which ranges from 1 to infinity. So we can conclude that our x squared all over n absolute is less than what? Epsilon. From the formula we say fn of x minus f of x absolute is less than or equals to what? Our x squared all over n, which should be equals or less than the interval. Let's take the interval of x to be from negative our x to be from a closed interval of negative 5 to 5, for instance. So we say our x squared over n should be less than what? 5 squared all over n, which should be less than epsilon. Here we use the capital N depended on what? Epsilon. So we can conclude this by saying the function fn of x uniformly converges to f of x at point 2x. That is what? Our end of proof. And that marks the end of testing for uniform convergence of a function. You can, if you like my video, kindly you can subscribe and share. Thank you for listening.